Assalamualaikum. Uh, we are from Group 6 to present Keyboard Polycc Ergonomic Design Analysis. Next. This is our team members, Ahmad Isra, Ahmad Amirul and Larry Shah. This is content, identification and management of potential risk. So first, introduction of Keyboard Polycc. Second, description of the product. Third, ergonomic features. Next, benefit to the user. Five, identify ergonomic problem. So, the introduction of Keyboard Polycc. Security, security and access control are very important in workplace, laboratories, and residential buildings. Traditional key storage systems such as manual cabinets are difficult to monitor and manage. They do not provide proper tracking, and keys can easily be lost, misplaced, or accessed by unauthorized individuals. To solve this problem, we developed an IoT-based smart keyboard system using RFID authentication. This system allows only authorized users to access specific keys, and all access activity are recorded in a cloud database for monitoring purpose. Uh, objectivenya, objective for the design. The objective of this project is to design and develop and secure an efficient 20-slot smart key management system. The system aims to improve key security, provide real-time tracking, reduce manual errors, and ensure that the design is user-friendly and ergonomic. Our focus is not only on security, but also on improving user comfort, accessibility, and operational efficiency. So next.
Good morning, madam. My name is Ahmad Ishraq Ona bin Abdul Aziz, and my message number is 24DKM24F1071. So today I will be presenting about the description of the product, which is the Keyvault Polycc. So let me begin with the description of the product. Our Keyboard Polycc consists of a cabinet that contains 20 individual key slots arranged in a structured and logical layout. So each of these slots is electronically controlled using a ESP32 microcontroller, which serves as the brain or the processing unit of the system. So the ESP32 controls the authentication, slot unlocking, data recording, and communication with the cloud database. So to access to take a key, user must first authenticate themselves using an RFID card. This ensures that only authorized individuals are allowed to retrieve the specific keys that they want. So when a user scan their cards, the system immediately verifies their identity against the registered database. So if the authentication is successful, the system automatically unlock the assigned key slot. So if access is denied, the system will display a clear message on the screen. So one of the key strengths of the system is its cloud integration. So every transaction, including the user ID, the access time, and slot number, it's recorded and stored in a cloud database. So this allows administrators to monitor usage history, track accountability, and maintain proper documentation if anything happens. Now, this feature is especially useful in environments such as laboratories, workshops, offices, or institutions where key controls are traceability, where key is important, and So let me describe what the product. So on the front panel of the cabinet. So let me describe what the product. So on the front panel of the cabinet, there's an integrated display screen and indicator lights. Um, um, so on the front panel of the cabinet, there's an integrated display screen and indicator lights. So this component provide real-time feedback and system status with slot availability and authentication results. So, for example, a message such as access denied or access granted is displayed clearly to guide the user. So, overall, the system combines mechanical structures, embedded programming, electronic hardware, and cloud connectivity into one complete product. So, now moving on to the ergonomic features of our design. So, firstly, I would like to begin with the anti-slip rubber base. So at the bottom of the valve, so we installed a high friction rubber layer. So this prevent the unit from sliding or shifting during operation. So when a user press the keypad and scan their RFID card or pull out a key, the cabinet remains stable and it doesn't move. Now for so this stability creates a solid and professional feel. So it improves both the safety and the user confidence. Now moving on to the second point is the smooth powder coated finish. So the cabinet is coated with a powder coat finish, a black powder finish. So this provides a smooth and comfortable surface for frequent touch. So since the system is designed for daily use, surface texture plays a very important role in this case. So additionally, the powder coating also is resistant to scratches, fingerprints, and oil buildup. Makes it easy to clean and sanitize and making it suitable for professional environments. Now, moving on to the third ergonomic consideration is the neutral zone component grouping. That's the RFID scanner, that's the keypad, that's the LCD display, which is all of them are displayed in a position where where you can reach it comfortably. So this allows the user to operate the system using natural arm movements without excessive stretching or bending. Now, so by placing these frequently used components within the natural reach and which is in the front, so we reduce the physical strain and improve efficiency during the repeated use. So next we have the eye level information display. As I've explained to you, that's a LCD screen. So the display screen is positioned at a natural viewing angle, so user can read their system messages without bending their neck downward or adjusting their posture significantly. And then there's the reducing neck strain. Is especially important in environments where the system may be used multiple times per day. As we all know, poly or other institution, they lock the door after the end of the day. So this is very important. So clear visibility also ensures that important status messages are immediately understood, minimizing the confusion. So there's another important ergonomic feature is the sequential 20 grid slot layout. You know, there's 20 layer, there's 20 light boxes for the key. So the key are arranged in a logical matrix pattern. This layout aligns with the natural human scanning behavior. So typically from left to right or top to bottom. So because of this structured arrangement, users can quickly identify their assigned slot without having to search it randomly. So this reduces the mental effort and improves overall workflow efficiency. And finally, we have the system that includes both the tactile and the visual feedback mechanism. So sorry, when a slot unlocks, user can hear and feel the mechanical click of the electronic lock. So at the same time, the display screen and indicator lights will provide a visual confirmation whether the access is granted and maybe a light turn green or red. So this dual feedback system eliminates uncertainty. So user immediately know that whether their action was successful or not. So this reduces the errors, prevents repeated input, and enhances overall usability. That's all from me. Thank you.
My name is Larisha. My metric card number is 24 DKM 24 F1052. Now I will explain the main benefits of our system from the user's POV. First, the system is designed to reduce physical strain. For example, the RFID scanner and display are placed at eye level within comfortable reach zone. This means users do not need to bend down or stretch awkwardly when using the system. As a result, it helps reduce fatigue and the risk of repetitive strain, especially for users who access the vault many times a day. Next, the layout of the 20 slot is clear and well organized. The grid-based design and high contrast finish allows users to quickly identify their assigned slot. This reduces search time, minimizes confusion, and helps users work more efficiently, especially during busy periods. The system also focuses on reducing operational errors. For example, with a simple interface, clear display, and LED indicators, users can easily follow the correct authentication steps. This reduces mistakes such as taking the wrong key or experiencing accidental lockouts. Another benefit is increased speed and accountability. Because the system supports a natural standing posture and fast check in and check outs, users can complete tasks quicker compared to manual logging. This encourages proper usage and better compliance with security procedures. Finally, the system offers a smooth and seamless user experience. For instance, the powder coated finish provides a professional look and is easy to clean, while the rubber base prevents the unit from sliding. This gives users confidence when interacting with the system and prevents accidental drops or movements. Overall, these features work together to make the system safer, faster, and more user friendly. Now I will present identified ergonomic problem. For this slide, we identified several ergonomic issues in the smart key vault system. First, RFID scanning may be difficult for elderly or disabled users. For some users may have limited mobility, poor hand coordination, or slower reaction time. Because of this, aligning the RFID card properly with the scanner could be challenging and may cause delays or frustration. Second, the system may require user training. Since this is an IoT based system, new users might not be familiar with how to use RFID. The display or the system interface without proper guidance may feel confused or make mistakes during operation. Third, the screen or indicators may not be visible in low light environments. If the system is placed in areas with poor lighting, users may struggle to read the display or see system feedback clearly. This can reduce usability and may increase the risk of incorrect operation. Overall, these problems highlight the importance of improving accessibility, visibility, and ease of use for all users to make sure it is all used properly and managed in good hands and provide comfort to all users.
Next, conclusion and recommendation. In conclusion, economic principles have been successfully integrated into the design of the 20-slot smart keyboard system. The, the slot arrangement, eye-level display positioning, and natural reach zone component grouping help ensure comfortable and efficient efficient user interaction. The system not only enhances security through RFID authentication and cloud data storage, but is also improve usability and reduce operating errors. For features improvement, we recommend adjustable mounting height to suit different users, a larger display screen to improve visibility, increase spacing between slots for better accessibility, and user testing to further optimize the ergonomic design. Overall, the system successfully combines security, IoT technology, and ergonomic design into a practical and user-friendly solution. So, thank you. That's for my group.